Good morning, class. I've had a lot of questions about question number 2, Unit 4, Activity 3, the population growth question. And I thought I'd just show you how to calculate, how to handle the formula, setting up a sort of a quick table of values and simply calculating the value of k, that constant that's in the exponential function, without using Curve Expert, without using some other methods. It's pretty straightforward, and I'm not going to solve the answer for you. I leave that to you guys to plug in that value of 87 minutes into my final function. But for the most part, I just wanted to show you how we can best handle it without using Curve Expert. Please feel free to use Curve Expert or any other means and methods you want to work with that function and to solve that value of k. But I wanted to take an opportunity to show you how to do it without Curve Expert and some other technology. Okay, here we go. Set up the table of values so that you get, okay, a real simple doubling problem here, that every 15 minutes the population starting at 500 doubles, so you can really quickly get okay, a quick table of values. The function we're going to use, the formula we're going to use, okay, is this one right here. We sub in our values, any two values of 1,000 and let's say 15, or the time of 15 and population of 1,000. Our initial value here of P0 is 500, and that's just e to the raised to the k 15. I've just rearranged that to 15k. Brought the 500 over to the left-hand side of the equation, worked it out. We get our final step here, 2 equals e raised to the 15k power. Now the trick to solve for k is to take the natural logs or the lns of both sides. I think we talk about this a little bit later. You may have seen this in some other classes. That gives the ln of 2, right? The left-hand side of the equation, ln 2 equals the ln of e to the 15k power. You apply at this stage here, you apply a real simple power rule. Bring the exponent down, so that's 15k times ln of e equals the left-hand side of ln 2. Ln e equals 1. You can do that on your calculator. You may know that as a given. So that can be crossed out. Okay, we would just neglect that. Go back to your calculator and evaluate the ln of 2, 0.69314178 equals 15k. Solve for k, so you divide that left-hand side by 15. You eventually work that out so that you get a final k value, okay, this constant in my exponential function of 0.046209812. You throw it back into the original equation, and that's what you're working with. Now, the question asks you to find the population when it would be 87 minutes. And hopefully we can do that here, where we just substitute 87 for wherever there is a t in my population equation. Hope that helps, and hope that shows you a little bit on how to solve for that value of k.